All right, so the next topic is called reduced row echelon form. Yes. So, I don't think... Well, we're going to do this by hand first. So I'm going to show you what reduced row echelon form is. Row reduced or reduced row, it doesn't matter how you say it. Show you what operations we can do by hand, how all that works. And then I'll show you how to do it on the calculator. Okay? I will expect you by hand to be able to handle a 2x2 by hand. 3x3s and other stuff we can do on the calculator. But it's good to know like what it all means. Okay, so let's take a system like AX plus BY equals C and DX plus EY equals F. So here's your ordinary 2x2 system. Okay, the first thing you do is you create what we call an augmented matrix. So it's kind of like two matrices in one. So on the left side, we're going to do a little 2x2. And all we're going to write down are the coefficients of x and y. So I'm going to put A, B, D, E. And then on the right side is going to be the answers C and F. Okay. Solving one of these systems by using reduced row echelon form is the process that takes this matrix, and instead of having A, B, D, E, we change it so that it's exactly 1, 0, 0, 1. And then now we have some new answer over here, which we'll call X naught, Y naught. Okay, so we're going to do some manipulations like adding, subtracting, multiplication, dividing. Okay? And eventually the goal is that this matrix will turn into what we call the identity matrix on the left. The identity matrix has a diagonal of 1s with zeros everywhere else. So if this were a 3x3, like if I had a 3x3 and then the answers over here.
Is it binary?
It's not binary, but I mean, zeros and ones are binary. For a 3x3, the answer is going to look something like this. 1, 0, 0, 0, 1, 0, 0, 0, 1. And then your X, your Y, and your Z would be over here. Okay, so again, the identity matrix has a diagonal of 1s with zeros everywhere else. Okay, and this is useful for us because if we can turn a 2x2 into this or a 3x3 into this, remember that this A represented AX, right? If it turns into a 1, then what does this mean? Just X. And if there's no Y's here, it's like I'm saying X plus nothing equals whatever's over here. Does that make sense? So this will translate to whatever this number is, that's our answer for X. X equals whatever that is. And this means that Y would equal whatever this number is. Does that kind of make sense? At least the representation part of it.
Yep.
And like here, this would mean X is whatever that is, Y is whatever this is, and Z is whatever that is. Now the point is, how do we get from here to here? So we're going to do an example. I'm going to walk you through kind of what I like to do for 2x2s. And then we'll go from there. Let's see. Let's do an example where we all know what the answer should be. Abby, give me a number. What is it? 9? So 9x. Ricky, give me another number. What is it?
28.
Let's keep them smaller, just since we're doing stuff by hand. 6. So let's go down by 6s. 3y, and then down by 6 again. Gives me -3. Kevin, give me another number.
7.
7. Okay. And Ida, give me a number.
2.
2s. Let's go down by 2s. Okay. That should have a nice answer. All right, so first, let's write this in the augmented format. And now what do we get? 9, 3, and then on the other side, -3, 7, 5, 3. Okay. Now, remember, the goal was to get a 1, a 0, a 0, and a 1. Okay? And here's what I recommend doing. Think of the letter C. Okay? So, you know how when you write the letter C, if you were to write the letter C here, you would start like this. Does that make sense? So this kind of reminds me of what order I should do things in, at least for a 2x2, and that's all we're going to do. Okay? So first, I'm going to try to get a 0 here, and then I'm going to try to get a 1 here, and then I'll get a 0 in the bottom left, and then I'll finish with getting my final 1. Okay, so if you guys can remember that order, that'll make things easier. Okay, so now how do we do that? Well, this 3 needs to go away then. What letter does that represent?
Y.
The y's, right? Do you guys remember how to eliminate y's up here? Multiply by -5, multiply by 3, and then you can add, right? So that's what I'm going to do. Okay, but what I'm going to do is write things concisely without having to write out all the numbers. So what I'm going to say is, I'm going to take -5 times row 1, and then I'm going to add that with how many times for the second row? 3 times row 2. Okay? So then that's going to give me a new matrix. And the way to do this is to remember that we're working in the first row, so my first row is going to change. I'm not going to do anything to my second row, though. So I'm going to leave that as 7, 5, 3. And now my first equation is going to change according to what I said I was going to do to cancel out those y's. So if I take -5 times row 1, and then multiply row 2 with 3 and add everything up, let's see what happens. -5 times 9 is what? -45. And now I'm adding 7 and 3, which is 21. So help me out. What's -45 and 21 when you add them up? Negative, right? Yes.
What did you just?
Yeah.
I multiplied everything in row 1
What did you get -5?
because we said to cancel out this number,
Yes.
we needed these to be the same coefficient. It's just like elimination, except I'm not actually writing out all the equations again, and I'm just replacing one row at a time.
So then why do you do no row 1 and 2 to replace the rows?
Yes, these are what we call row operations. You can add rows together, multiply rows together. I'm sorry. You can multiply a row by any number, and you can add rows together. So what I'm doing here, in order to get this to be 0, I'm making this a -15, I'm making this a +15, and then adding them together.
You just took the first row.
Mm-hmm. And I'm not changing the second row at all.
But what are you multiplying with the first one? Put -24. What are you multiplying?
So I'm just taking the first number,
Yes.
multiplying it by -5, and then taking the second number here, multiplying it by 3. So this is -45, this is 21, and when you add them up, you get -24. Okay? It's a little weird because usually we rewrite both equations, okay, but we're only changing one of them, okay? So now what's going to happen here?
0.
You're going to get 0 because I get -15 and +15 added together give me 0. Do you guys see that? And now for the last number here, again, it's the same thing. -5 and -3 is 15, and now add that with 9, we get +24. Right? So first step is done. You see how I got my 0 there? Okay? And now, again, the rules are that you can multiply a row by whatever you want, and you can add rows together. I could multiply the first row by what to get this to be exactly 1? What do I multiply it with? Negative 24 times what is going to be exactly 1? Negative 1 over 24, right? So then, my next phase, this negative 24, I'm multiplying it by negative 1 over 24, which is really the same thing if you want to think of it this way. I'm just dividing by negative 24, right? So what do I get? 1. 0 divided or multiplied by anything is 0. And now 24 times negative 1 over 24, negative 1. So what did we just figure out? Which tells us which variable? X. So we know now that x is negative 1. Okay? Now let's work on row 2. Let's work on row 2. Yes?
Where'd you get the 7, 5, and 3? Is it the second?
That's the second equation.
Wait, how do you know that's 1? Or it's negative 1?
Because 24 times negative 1 over 24.
No, how do you know that's x?
Because this represents the x's, this represents the y's. So if this says 1x plus 0y equals negative 1, essentially it just means x is negative 1. Like if you actually wrote out the equation it stands for. Does that make sense? Okay. Everybody good so far? Okay. So now, we got the 0 here, we got the 1 here. Next we're going to get a 0 down here. Okay? So again, we have to multiply and combine or add rows together. If I want this 7 to go away, I need to add negative 7 to it. Does that make sense? Where can I get negative 7 from?
Negative 7R1
There we go.
plus R2.
So if I multiply the whole first row by negative 7, and then add with the second row,
Oh, wait. So it's not the old equation.
we're still leaving the first row untouched, because that's done, right?
So that's the new equation.
Yes. So we're just doing negative 7 plus 7 gives me 0. 0 times negative 7 doesn't do anything. But now I'm adding 5 to that. Negative 7 to the first row gives me a 7. And then I'm adding 3 to that. So that's 10. Okay? So, almost done. There's only one more step, right? We take row 2 and multiply it with what? With 1/5, or divide by 5, if you want to think of it that way. Bless you. So we get 1, 0, negative 1, 0, 1, and then 10 becomes 2. So our solution, as we said, should be a nice answer. X is negative 1, and Y is 2.
Is it supposed to be in a coordinate?
Yes. You guys want to do one more together?
Wait 1 sec.
No, you got it? Nate says, yeah, ready to go, and everybody else is kind of, oh, Jack?
I don't understand step 4.
Step 4, right here.
Yeah.
We want to turn the 5 into a 1.
I don't even understand how you got the 0 to the left side on.
So you want to make 0, 1. This needs to be 0. In order for this to be 0, you have to add negative 7 to it. The only way you can get negative 7 is if you take the first row and multiply it with negative 7, and then that gets added with row 2. Think about elimination. That's essentially what's going on. So like this translates to what? X plus 0y equals negative 1, and then 7x plus 5y equals 3, right? If you had to cancel out these x's, what would you do? Multiply this by
Okay.
negative 7, add everything up, right? And then what you get is this. Because you would get 5y, right? And then positive 7 and 3 gave you 10. So this is what this represents. We're just not writing out all the equations every time and then going in there. Okay?
How did
We'll do another one.
Can you look at can you spell the part where, like,
okay? No, you go.
like the first part when you did the negative 5 row 1, or like multiplied it plus
This part?
row 1, yeah, row 1 or row 2 times 3. Like how you got
How we got, hold
2,
on.
like the negative 24 and then the 0 and then 24. Like how you do it. If we do like
Yes, I'll go, yes. Okay. All right. Let's try another one. Do you want to create one that's got the same answer, or do you want like a different one? Just, okay, hold on. Give me a minute. Let's say we have x plus 3y equals 11, and then 3x minus 2y. Hold on, I gotta think about this. Equals 5. I think I made it so it works out nice. Okay. So first, let's write it in augmented form. So the first row will be 1, 3, 11, and then 3, negative 2, 5. Okay, so let's go slow. The first thing I want to get rid of is what? Which 3? The top right 3, right? Now, if this 3 is to go away, I need to add what to that? I mean, there's one way to do it. You could say I could add negative 3 to it, or say, well, there's no way to do that nicely. So first I could make this a 6, and then make that a negative 6, just like if we were to eliminate, right? Like, look at the original equation. If you wanted to cancel these y's out, what would you do? 2 and 3, and then what? Add. Well, guess what? I'm doing the same exact thing here, okay? And I'm just going to write it out as 2 times row 1, because that's what this represents, is this first equation, right? And then I'm adding that with 3 times row 2.
So are you okay? So if you looked at the top equation and then you did it like normally, like algebraically,
Yes.
can you just do it like that and then move the numbers to brackets? Or is
Yeah, I mean, that's essentially what we're doing. So if you just remember that this is going to cancel out and become 0, right, then that's fine.
Why can't we just do it that way then?
It's a different method, Saeed, that defeats the purpose.
it's just the way that you write, like with the rows.
Yes. I mean, we could just graph these in a calculator if we wanted to,
Oh yeah, that one's good.
right?
Wait, so like if you did it like that, would the first number of the second one be 2 like that? Or would you, like, because on the other one you left the bottom row the same first. And
So, yeah, the bottom row I'm not going to touch. I mean, you could change it, but changing each row, each step of the way is going to make it bigger. The point of this is we want to keep things as small as possible. Okay? So all I'm doing is canceling out this 3. All right? And here's how we do that. We take double of row 1, triple row 2, and add everything up. So let's do that. This becomes 2. Triple this number. 9. What do we get? 11. Double this number, triple that number, add them up. 0. Double this number, triple that number, add them up. Oh man, did I do this poorly?
Yikes.
Sure did. Okay, that's fine. So what do we get?
37.
37. Okay. Now what's the next step?
Gotta make that 11.
This 11 needs to be a 1. And again, if it helps, what does this first row actually mean if you wrote it out? It means 11x equals 37. How would you get x alone? Divide by 11 or multiply by 1/11. It's the same thing, right? So we're going to take first row and multiply it by 1/11. Rewrite the matrix. So now we get 1, 0, and then 37 times 1/11 is 37/11. Sorry, I must have made the numbers. Oh, wow. There's the issue. Okay. Second row stays the same. All right. Are we good with what we've done so far? First row is transformed. I got the 0. I got the 1. What do I do next?
Make that 3 a 0.
Make this 3 a 0. We could eliminate the 3 if I multiply the top equation by -3 and then added them up, right?
Yeah.
So take top equation or top row, multiply it with -3, and add that to the second equation or the second row. And now my next step gives me 1, 0, 37/11. And now let's do this slowly. -3 times this first number is -3. Add that with just whatever that is, so that's 0. -3 times 0 is 0. And now I'm just going to add -2 to that. So -2. And now here we're going to be careful. -3 times that. So sorry, I made a mistake in my head when I set this up. I have to do that by hand. What's 37 times 3? 111. And that should be negative, right? Did I do that right? -3 times. Oh, but I didn't add
5.
I didn't add 5 to that yet. So scratch that. 111 over 11, and I add 5 to that, so it'd be like adding 55.
166.
So it should be
166.
-56
166 over 11.
111 over 11 and
plus
then plus 5.
5, yeah.
Negative
-56 over 11, right?
Oh, just go.
Is that right?
Yep.
Okay. One more step.
Yeah.
How do I get rid of -2y equals multiply by -1/2, right? So -1/2 times the second row, and I'm done. So 1, 0, 37/11, 0, 1, and now -1/2 times -56 over 11, 56 over 22 is what I'm getting.
Positive.
Positive, because it's a -1/2 times a negative. Oh, it does reduce, right?
28.
28 over 11?
Oh, yeah.
Okay, thanks, guys.
Over what's
Yeah, no problem.
So now, so on a calculator, okay, there are some special cases that will probably come up in the homework, which we can clear up tomorrow, but I think on the homework it'll say, do these problems by hand and then do these with the calculator, okay? There will be some 3x3 questions. Do not do them by hand with reduced row echelon form. Do them in the calculator. Here's how. Okay, very easy. Let's take the first example, this one. You guys remember what the answer was? -1 for x and y was 2, right? So here's how you do this in the calculator. Go to the matrix menu, edit, and we're going to make one matrix that has 2 rows and 3 columns. And then we just enter everything. 9, 3, negative 3, 7, 5, 3. Quit out of there. Go to the home screen. Go back to the matrix menu. And now if you go to math, there's all these things that we can do with it. If you scroll down, somewhere there should be reduced row echelon form. Right here, option B. Okay, so you take option B. And now what are we doing that to? To what matrix? To matrix A. And there it is.
Wait, what tab is it under?
That's the answer.
That's the answer. It's under the math menu.
Well,
Math and then.
What is going on?
RREF. If we do the second one,
Let us know something.
I don't have that.
well, this is the fastest way to solve matrices on a calculator.
why don't we just
I got it. Figured it out.
Let's see. The second one was... Guys, don't pack up until it's time to go.
The bell is not
1, 3, 11, 3, negative 2, 5. If we do the same exact calculation, we get this ugly thing. But how do we get fractions?
math.
Oh my god.
Follow the directions on the homework. We'll go over stuff tomorrow. What's up?
Where's math? Correct.
Math. Fraction. I haven't looked at it yet. It's still sitting on my desk. That's why it says missing. Yes.
I'm out.
So it should be entered today probably.
Okay.
All right.
Thanks.